Hi, everybody. I hope you can hear me. I hope you can see me. Welcome to our first breakout session. It's about 100 and 400G breakout solutions or high-speed interconnect solutions. Sorry for mixing that one up. Um, so 100G has already been around for a while, and 400G is the new kid on the block. We are at DE-CIX currently also in a pilot phase of reviewing 400G technologies for our own backbone. So for everybody that does not know me, my name is Bernhard. I'm from DE-CIX. I'm the head of global infrastructure, and by that responsible for our global deployments as well as the operations of our infrastructure. So when I'm not moderating breakout sessions, I'm usually deep in the operations here at DE-CIX. So we will now start with our first breakout session. Welcome Matthias Kayser from Smartoptics. He will now tell us a few words about solutions for 100 and 400G solutions. Matthias, the stage is yours.
Yeah, Bernhard, thanks for giving us the opportunity to fill the slot with some exciting news about 400 gig, 100, 400 gig interconnect solutions. So I will try to keep it quite technical, although, of course, you know, Smartoptics are a provider of, let's say, DWM solutions in this space. But let me start right away. So to give you a short idea of what I'm going through today, short introduction and motivation for this session, some updates about 400 gig ZR standards and technology, 2 slides about 400 gig ZR performance and some challenges with regards to 400G, and then I will conclude with a few words about mixing 100 gig and 400 gig in existing line systems and the customer case and what that might mean for the future of DWM and cloud DCI and internet exchange interconnectivity. So when I just look at what DWM technology in enterprise and service provider networks means today or meant in the past, in enterprise and data center internet exchanges, it was all about cost-effective solutions, space power saving, easy to use. So far, it was mainly metro distances because long-haul services have been usually rented from the carrier services, and it was mainly point-to-point within the metro, let's say a major city like Frankfurt, Amsterdam, or London, and so on. And it was all about really high bandwidth. So it wasn't like 100 gig here or there. It was massive bandwidth. However, in the past, I mean, it was very popular to use passive DWM multiplexers with just embedded optics. And in the data center today, it's mainly SFP+, QSFP28, and with 400 gig QSFP-DD coming down, which had a few pros and cons, of course. And the main con was that these were not available for long distance DWM applications. So when enterprise customers, data centers, cloud providers wanted to go longer distances, they usually had to either take telco class DWM systems or they had to lease managed services from the telco service providers. On the other hand, the telco and service providers, they usually build long distance networks with more complex technologies like ring mesh for all kind of services, and they usually wanted a demarcation to separate their network from the customer network. And overall, that meant that this is a way more sophisticated technology, usually transponder or muxponder based, and the main DWM interfaces were either fixed optics or CFP, CFP2 transceivers with higher performance than the ones which were used in data center switches and routers. So looking at the way many cloud providers build networks in the metro in the past or still today, it was mostly transponder based or muxponder based. That means the router or switch is interconnected with a transponder using short reach optics or with a muxponder using short reach optics. And then the transponder or muxponder operates on a 100 gig tunable coherent wave over a line system, which can be different vendors of DWM systems. In about 2017, 2018, Inphi has released a DWM QSFP28 known as Colors in the market, where Smartoptics was one of the few vendors picking this technology up and developing a specialized line system for these so-called PAM4 transceivers, because it was the first type of transceiver using PAM4 modulation on the optical side, to build the embedded DWM interconnect solutions for point-to-point applications. I mean, there were quite a few benefits. That's also why we have sold about 1,500 of these line systems till today. It's low cost, low power consumption, small footprint, low latency. But there's one drawback. The line system is quite optimized for this transceiver type, and it only works over metro distances. So no way taking these QSFP28 modules over more than 80 or 100 kilometers. So when we look at 400 gig now, 400 gig comes in two flavors, and I will come to the details on the next slides. So today, customers have still the opportunity to build their networks in the conventional way, like using transponders or muxponders, multiplexing, let's say, several hundred gigs into a 400 gig wavelengths and running it over legacy transport network. I mean, the advantages here are still that these CFP modules have a slightly higher TX power, allows customers to run them over existing DWM backbone networks. It's ideal for brownfield. You have a clear demarcation point through the muxponder and transponder, but you're still locked into these vendor-specific, let's say, optical management systems and traditional DWM solutions. A new way building these networks today could be the embedded approach again. So with QSFP-DD coherent in a switch or router, customers could now start to build their DCI, metro, or even regional networks interconnecting major cities in different countries with a DWM transceiver plugged into the router, operating over a transport network, either point-to-point or even open ROADM-based or kind of disaggregated DWM solutions, with all the benefits of lower cost, lower power consumption, smaller footprint, no transponders or muxponders needed anymore. And that brings me to the 400 gig ZR technology as is. So there are 3 different standards as of today. One is the OIF 400 gig ZR, one is the Open ZR Plus MSA, and one is the Open ROADM standard. And all 3 define different kind of applications and use cases for these 400 gig ZR or ZR Plus optics. So the OIF is mainly focusing on edge DCI campus solutions with reaches up to 120 kilometers, but only for 400 gig as a client format. So there's no way to scale these down to 300, 200, or 100 gig. With some technical implications like FEC and modulation format and so on. There's the Open ZR Plus for longer reaches with 3 options of modulation formats and different types of FEC. This is actually more flexible, allows longer reach, and also allows to reduce the line capacity in order to get longer reach, of course, for the cost of lower data rate. And then there's the Open ROADM, which is mainly for, let's say, long reach applications in the carrier space. So these 3 standards will come in 3 different flavors of transceiver, pluggable transceivers. The QSFP-DD is probably the most popular in data center, cloud environment, with some OSFP switches available in the market. And the CFP2 will most likely be more the one for traditional approach in transponders and muxponders of telco class DWM systems. So we're focusing on the QSFP-DD form factor today because it's the one which will, let's say, be ideal for embedded DWM applications. So when we look at the Open ZR Plus or ZR standards, it is way more complex than conventional, let's say, transceiver standards in the past. There are quite a few application modes defined in the standard, and most vendors will probably start to support the first 2, which is 400G base over short distances in the metro, up to 80 kilometers with amplification. But there are a few more which are of interest in, let's say, long reach applications or in combination with max Fonda applications. Here we can go with, let's say, 300 gig, 200 gig, or 100 gigabit data rate to longer distances up to 2,000 kilometers. And these are all standards, and where transceiver vendors can decide which operating modes they want to support, and switch and route vendors have to decide which of these application modes they want to support, and what will they allow their customers to do with these transceivers. Here I wrote Smartoptics Setup Plus transceivers. That's because, I mean, this is the first released transceiver we will have available. It's not given that all vendors will actually support all these operating modes, but time will tell. So 2 application examples for these new optics, of course, embedded 400 gig ZR in a router or in a switch over a transport network, point-to-point, or more complex ROADM, or as well multiplexing 4 times 100 gigabit into a 400 gig, or with lower line rate for longer distances, maybe 3 or 2 times 100 gig into a 200 or 300 gigabit wavelengths. This again allows customers to build quite high bandwidth networks in a very efficient way. So when we look at 400 gig ZR optical performance, there are a few things to consider when planning this kind of network. First, it is an extreme complex technology. So it's not a standard OEO or EO transceiver anymore, converting an electrical signal into an optical signal like for many generations in the past. It's a combination of a pulse amplitude modulated electrical signal, which gets converted in a digital signal processor into 16 QAM coherent DWM signal, tunable over the full C-band, with a lot of optical components integrated, which do the, of course, conversion, digital, analog, digital, and the modulation and compensating for dispersion and so on. So it's a kind of a, let's say, sophisticated DWM transponder in a pluggable. And that's opening up for a lot of new applications. However, with these new modulation formats, there are a few, let's say, things to consider. One is the extended bandwidth requirement in the spectrum. So when we look back to 10 gig, that was a pretty narrow peak signal in an ITU channel. 100 gig QPSK was slightly wider, and with 200 gig QPSK and 400 gig 16 QAM, we now need like 60 or 65 gigahertz bandwidth within an ITU channel in order to multiplex these signals and avoid penalties when transmitting over distances. When we compare with the Inphi Color Z transceiver, that transceiver was operating at 2 optical carriers, 25 gigahertz shifted from the center frequency, and already required high bandwidth as well. So it's not too far away from this 100 gigabit PAM4 transceiver when it comes to customers wanting to use the 400 gig ZR online systems, which already support the PAM4 transceiver. But for customers who run, let's say, 10 gig or 100 gig QPSK signals through their network, this might be something to consider. And in more detail, so when using thin film filter DWM multiplexers, many of these filters have been designed for, let's say, 10 gig networks in the past. Most of these filters have just 30 gigahertz of bandwidth. Some are going up to 60, but with a 400 gig modulated signal requiring 64 gigahertz of bandwidth, you will already see some penalties. So you can't get the full performance of a 400 gig transceiver and full distance. With DWM AWG filters operating at 100 gigahertz grid, the the bandwidth might be sufficient, but now the problem with the optical power budget kicks in, because 400 gig ZR transceivers only have about 11 dB optical power budget, which means that without amplification, there's no way to take these signals over an existing passive DWDM link, which might be good enough for 100 gig or 10 gig on metro distances. So what does that mean? You either need new filters with wider passband or additional amplifiers or all together. Or of course, when you install new solutions for, let's say, adding capacity, you can go straight for a 400 gig optimized line system. So we've done some calculations and measurements how far 400 gig ZR plus can reach in realistic network scenarios. With a 400 gig ZR, we have a OSNR tolerance of about 26 dB and dispersion tolerance of 2400 picoseconds. That means we can go with regards to dispersion tolerance about up to 120 kilometers. And with regards to the OSNR, we can make about 3 hops in a kind of ROADM network or in a link passing through, let's say, 2 data centers. With 400 gig ZR plus, we have a better OSNR, better dispersion tolerance. So at 400 gig, we can reach about 5 hops and way better distance with inline amplifiers or passing through several of these ROADM nodes. And if we start reducing the data rate to 300, 200, or 100 gig, we gain OSNR and we also gain dispersion tolerance, which means we can go way further. So with 300 gig, you can expect to reach, like, let's say 600 kilometers. With 200 gig, I think beyond 2000 kilometers, and with 100 gig even more. So the performance of these transceivers is amazingly good and really allows for new design of DWDM networks today. So many customers have already deployed 100 gig PAM4, and I guess there are some listening today. So what does it mean if you have a 100 gig PAM4 line system already and you want to go for 400 gig? Yeah, to keep it short, I mean, PAM4 and 400 gig ZR have similar output power. They have similar OSNR requirement. They have similar bandwidth requirements, which means that they very well work on the same line system without any penalties, as long as we are in, let's say, metro distances. There are a few nonlinear penalties to consider, but let's say on the link distances, we have deployed the systems so far and specified. It usually is no problem running both together. When building new networks, of course, it's possible to build a line system which is optimized for 400G and can be cost and performance optimized for even longer distances. So we don't need to actually plan for the PAM4 OSNR and the dispersion compensation required by the PAM4 transceivers. I mean, this has been verified in our lab as well as with some customers already. And there was also a public announcement of Verizon Media building a trial together with Arista and Inphi back in September 2020. So that's available on this link here at the bottom. So that's about to my end. So one customer network we have already deployed today. You may have read our press release. It's an operator in Central Europe who has built 400 gig rings in the country. Each ring consists of 6 to 8 nodes, and it's using all the different options of running 400 gig in a network today. So some 400 gig links are running directly on dark fiber. Some are running with just passive DWDM multiplexers on short links. And wherever the link distances were longer or fiber constraints did not allow to use multiple fibers, they used an optical line, open line system. And the beauty of the solution was that they could upgrade their existing 100 gig PAM4 links with 400 gig, and on some links where they wanted to go straight for 400 gigabit, they installed a 400 gig only line system. So overall, I mean, it's significantly reducing the amount of network equipment by using this embedded approach. It's just a 1 U box per direction per site for the line system, and embedded optics with low power consumption, small footprint, and so on. And yeah, here on the right-hand side, you see an example of the router output, which provides all the information you expect from a layer 1, let's say, circuit, providing RX, TX optical power, chromatic dispersion, FAC errors, OSNR, and bit error rate. So that's short summary about what I've said today. So in my view, or in our view, 400 gig ZR Plus is not just a new transceiver type with a higher data rate. It's really a highly sophisticated part of a DWDM transmission system, which now gives customers new ways to build long-distance ROADM networks within the metro, but also between data centers across borders. And I think it's following the trend of disaggregated and open systems, and also opens up for integrating layer 1 into SDN solutions, which is also a big trend in the data center and cloud community these days. So that's it from my side today.
All right. Thanks, Matthias, for that great overview of 400 as well as 100G applications. Yes, as you already mentioned, it looks like things are getting more complicated. It looks like there are many new ways to achieve our goals in interconnecting our infrastructures. So we still have a few minutes left within our slot that we can use for question and answers. So you have the possibility to write your questions in the slide tool that you have within talk. So if there are any questions, please let us know. I think Matthias is happy to answer them.
Yes, of course. So no questions right away. Of course, you can always email me. You see my email on the right-hand side in the last slide. I think that's not online anymore, but.
All right. So if there are no questions, thank you very much.
You're welcome.
We are ahead of time. So it's 20 minutes to the next breakout session slots. So you have the possibility to get in touch with each other, do some matchmaking, and yes, see you soon. Thank you.